Hello, good evening all.
Good evening, ma'am.
So today we will be talking about Neptune, Uranus, then Moon. Okay. Now let's talk about Uranus. Uranus is the seventh planet from the Sun and the third largest planet in the solar system. So which is the third largest planet in the solar system? That is Uranus. And Uranus is one of the four gas giants in solar system as well as one of the Jovian planets. And it is also sometimes called the twin planet of Neptune. So these are some of the facts about Uranus. Is coming in the coming slides. So let's talk about the history of Uranus. How did we found about this planet? How did Uranus get its name? It is named after the ancient Greek god of the sky, Uranus. Ancient Greek god of the sky. So Herschel, who was one of the discoverers, he wanted to call it Georgium Sidus, and some named it George III's Neptune and Great Britain's Neptune. Some other people suggested Hipperonius and Trans Saturnus. Then there was a name called Minerva, which was proposed. Finally, the editor of Berliner Astronomical Laboratory opted for Uranus, and that came into effect. So thus the name of the planet, seventh planet from the Sun, Uranus. And this is the symbol of Uranus. H in the symbol taken from the discoverer's last name, Herschel. Now about the size of Uranus. The diameter of Uranus is 51,118 kilometers across, and its total volume is 6.8 into 10 raised to 13 kilometer cube. Mass of Uranus is in the order of 10 raised to 25 kilograms. Now the composition of Uranus. See, in the inner core, it is a rocky one, a solid one, and above that there is highly compressed liquid water and ammonia. And in the outermost region, there is liquid hydrogen and helium. So this is almost safe for both the planet, for Uranus and Neptune. That's why we call them twin planets. So these are the three layers: the rocky core in the center, icy mantle surrounding that, and an outer gas envelope of hydrogen and helium. This is the structure of both the icy planets.
Ma'am, the structure of Uranus and Neptune are same.
Yes, that is it. It's same. Now the atmosphere of Uranus. The atmosphere of Uranus is composed mainly of molecular hydrogen and helium. And third most abundant molecule after hydrogen and helium is methane. So what are the components? Hydrogen, helium and methane. And the axis of Uranus is tilted at an angle of 98 degrees. That's why it's called a rolling planet. See, look at Earth. Earth's tilt is 23.5. Jupiter's tilt is just 3 degrees. Saturn has some 27 degrees. So Uranus has 98 degrees. But Neptune, we'll talk about that in the coming slides, okay? And Neptune has 30-degree tilt. It could happen of many reasons. It's coming in the next slide. Actually, one hypothesis is one large object, celestial object of a big size might have collided with it. That might have, increased the tilt of its rotational axis to this much. Okay.
Okay, ma'am.
Yeah, the gravity on Uranus. Gravity on Uranus is 89% of Earth. Now, about the temperature of Uranus. The average temperature of the cloud tops on Uranus is minus 153 degrees Celsius. and up to -218 degrees Celsius. That is very cold, right? But temperature inside can reach up to 4,727 degrees Celsius. So inside it is very hot and outside in the cloud tops it is very less. Just like Jupiter also. Jupiter also we encountered the same thing. A thick tempestuous atmosphere with winds blowing. Yeah. Look at the cyclones present in the atmosphere of Uranus. Winds can even blow at a speed of 900 kilometer per hour. That is huge, right? Usually in bike or in cars, we go up to some 150 kilometer per hour or 180 kilometer per hour. That is even very fast. Now see the next slide. Yeah, the position and movement of Uranus. Like we said, it is the seventh planet from the sun. And how long is day on Uranus? A day on Uranus is 17 hours and 14 minutes 24 seconds. So which means one day will be just 17 hours, less than Earth actually. And how long is an year in Uranus? That is actually more. Uranus takes 84.3 years to complete its orbit around the sun. So how many years it will take? 84.3 years to complete its orbit around the sun. And this is the distance from the sun. The closest Uranus can get to Earth is 2.57 billion kilometers. So here you can see the elliptical orbits of different planets. So this is of Uranus, you can see here, and this bigger orbit is of Neptune, and here the orbit which is not in the plane, that is Pluto's. So now let's have a look at Uranus moons and rings. Uranus has 27 known moons, and the moons are all made of ice and rock. Most of the moons appear to be captured asteroids due to their size and orbits. These are the names. You don't need to study about all the names, but just I'm telling you: Miranda, Ariel, Umbriel, Titania, Oberon, Cordelia, Ophelia, Bianca, Cressida, Desdemona, Juliet,
Now I
Portia.
want to say a fact about this Uranus moons. All the Uranus moons which are named by the name of the William Shakespeare characters.
Yeah, I was about to ask everyone that. Have you heard about these names? Juliet, at least some of the names you must have heard, right?
Miranda, Ariel, and all.
Yeah, Miranda, Ariel, yes.
Oberon, ma'am. I had noticed through my telescope or Uranus, ma'am. I saw Ariel and Oberon, ma'am.
Okay, very good. And these are the rings of Uranus. The rings were discovered from the Earth in 1977. And some data suggests that Uranus was surrounded by at least 5 rings. Later, 4 more rings were suggested. And again, 2 more additional rings were discovered by Voyager 2. So these planets are like outer planets. There are a lot of things yet to be studied about these planets. More and more missions are needed to study about those. Yes, so yeah, the exploration of different satellites already has gone to Uranus. Let's say one of it is a flyby mission of Voyager.
Ma'am, Voyager 1 is not, we are not getting the signals from Voyager 1.
My screen got stuck. Let me see. Now Voyager 2, Voyager 1, it made a closest approach to Uranus on January 24, 1986, coming within 81,500 kilometers of the planet's cloud tops. The presence of magnetic field at Uranus was not known until Voyager's arrival. The intensity of field is roughly comparable to that of Earth, so it is feeble, though it varies much more from point to point because of its large offset from the center of Uranus. So we are not sure of the magnetic field yet, but now we know that there is magnetic field and it's not that. Yes, the peculiar orientation of the magnetic field suggests that the field is generated at an intermediate depth in the interior where the pressure is high enough for water to become electrically conductive. Okay, so this is the reason why there is a magnetic field in Uranus. What is it? The presence of magnetic field at Uranus was not known until Voyager's arrival. The intensity of this field is roughly comparable to that of Earth's, though it varies much more from point to point because of its large offset from the center of the Uranus. So we know that our magnetic field, Earth's magnetic field, it is centered in the center of the Earth, right? While the magnetic field of Uranus is not centered in the center of Uranus but somewhere else. Why? It's because a particular orientation of the magnetic field suggests that the field is generated at an intermediate depth in the interior. Okay, where the pressure is high enough for water to become electrically conductive. Since it is formed underneath the surface of Uranus, but not the center, this intermediate depth where pressure is very high so that water becomes electrically conductive. So that is why the movement of water makes it, you know that the mantle of Uranus is liquid and so the movement of the liquid makes a magnetic field. Voyager 2 found that one of the most striking influence of sideways position of the planet is its effect on the tail of the magnetic field, which itself is tilted 60 degrees from the planet's axis of rotation. The magnetotail was shown to be twisted by the planet's rotation into a long progressive shape behind the planet. So, whenever the magnetic field is interacting with the sun's solar wind, it takes a particular shape. Also, Voyager 2 is the only spacecraft to visit Uranus imaged a bland looking sphere in 1986. When Voyager flew by, the south pole of Uranus pointed almost directly at the sun because Uranus was near its southern summer solstice. Since there is this axis tilt, of course it will be having, seasonal changes. Yes, so this is our Uranus slide. We will quickly go to the Neptune slide. I will make it full screen. Yes. Yeah. This is the other blue planet. We know that Earth is called the blue planet, right? Sometimes Neptune is also because its color is blue. That's why. Now, Neptune is one of the four gas giants in solar system, as well as being one of the four Jovian planets. As a gas giant, Neptune has no solid surface. So even if a spaceship could reach it, it could not land because it would simply keep shrinking into the planet. Neptune cannot be seen with the naked eye and was therefore not discovered until 1846. And although Neptune is a gas giant, it is actually in a subclass of gas giants called the ice giant. It has a high percentage of ices in its atmosphere, just like Uranus. So this is the god of sea, right? So these are the two scientists who are behind the discovery of Neptune. The first one is Britain's George Couch Adams, and the second one is France Urbain Le Verrier. Britain's John Couch Adams and France Urbain Le Verrier were worked out the positions of the hypothetical eighth planet independently from each other. So both were working and both had a difficult time convincing their colleagues to spend any time actually looking where the suggested and planet might be. So, they were both of them, one at Britain and the other one at France. Both of them were independently working on, to find this planet. But, their colleagues were not even, listening to them. They were told that what, how can we propose or just hypothetically, um, find a planet just like that. But the Berlin Observatory astronomer, this person, Johann Gottfried Galle. He used the calculations by Le Barrier to find Neptune within just 1 degree of its predicted location and just 12 degrees of Adam's prediction. So, how did Neptune get its name? It was named after the Roman god in mythology, Roman god of sea in mythology, that is Neptune, also known as Poseidon in Greek mythology. Now, shortly after its discovery, Neptune was only referred to as the planet exterior to Uranus or Leverrier's planet because he was the one who proposed it, one of the scientists who proposed it. And the first suggestion for a name came from Johann Galle. He was the one who found using the telescope and who proposed the name Janus. Another proposal was Oceanus. Urban Le Barrier, who discovered the planet, claimed the right to name his discovery, and he named it Neptune. This is a symbol of Neptune, the trident. Now let's,
Ma'am,
yeah, yes, please.
ma'am, can you go back to the previous slide? Yes, ma'am. No, ma'am. Ahead. Okay, ma'am.
Yeah, so this is the composition of planet Neptune. In the center part, there is core of rock and ice, and above that there is mantle with water, ammonia, methane, ices. Then in the atmosphere there is hydrogen, helium, and methane gas, and there is upper atmosphere with in the cloud top. Look at this upper atmosphere. This image shows bands of sunlit cirrus-like clouds in Neptune's northern hemisphere. These clouds cast shadows on the blue cloud depth 35 miles below. White streaky clouds are from 48 to 160 kilometers and or 30 to 100 kilometers wide and extended for thousands of miles. And it contains 80% of hydrogen, 19% of helium, and 1% of methane. These are the components of Neptune's atmosphere. Neptune's atmosphere has 80% of hydrogen, 19% of helium, and 1% of methane. Now, Neptune's mantle. Neptune's mantle is a superheated liquid region where the temperatures can reach up to 2000 Kelvin. 2000, yeah, it's very huge. 2000 Kelvin to
Yes, Miss. Like
5000. Yeah. The surface of the sun, right? The photosphere.
The surface of the sun is 5800 degree Kelvin.
Sorry.
The surface of the photosphere of the sun is 5800 degree Kelvin.
Yeah, 5,000-ish degrees Celsius, right? Yes. It's
5
actually
to 6000.
yeah, it's actually 5,800 Kelvin. Anyway, yeah, that's right. Now it consists of water, ammonia, methane, and other compounds. The core of Neptune is made of iron, nickel, and other silicates that make up about 1.2 times the mass of Earth. The core itself has 1.2 times the mass of Earth. Now
Ma'am?
about yes.
What is the meaning of silicates?
Oh, silicate means the silicon related compounds. For example, if you talk about rocks or sand, it's silicon oxide.
Miss, it means the presence of silicons in an element.
Yes. So it's many such molecules can be there. Actually, silicate means what to say, salt containing anions of silicon and oxygen. So basically, they are silicon and oxygen, and also some other salts attached to it. Okay.
Miss, silicon oxide is sand.
Yes, that is true. SiO2. Now, this is the gravity of Neptune. The surface gravity of Neptune is 1.14 times the gravity on Earth. Only 1.14 times because the volume means density is less. Now, the axis tilt of Neptune. Neptune has an axis tilt of 28.32 degrees. Compared to the Earth's tilt, it is 23.5 degrees. At its surface, where the clouds of the planet touch space, the temperature of Neptune can dip down to 55 up to minus 218 degrees Celsius. Now, the average temperature of Neptune is minus 200 degrees Celsius. But look at the core temperature. Of Neptune, which is 7,000 degrees Celsius.
It is warm. That is warmer than the temperature of the photosphere of the sun.
Yeah, that much warmer. Now let's talk about the. Everybody, please mute some noises coming.
That's the photosphere, right?
Yes, hotter than the photosphere.
Ma'am, can you go to the previous slide?
See, you'll get these slides.
Okay.
If you miss the slides, also no problem.
Uh,
But yeah,
I just wanted to see the temperature.
Yeah.
Yes, you can proceed.
yes. And please, everybody, please mute your system. Chakri, some noises coming from your system.
Ma'am, I have heard the surface temperature of Neptune is minus 307 degrees Celsius.
Yes. Please
Ma'am,
mute. Yeah.
Minus 307 degrees Celsius. That is not possible. It is less
only
than 0 Kelvin.
270.
Nothing can be colder than minus 273 degrees Celsius.
Let me see. Where is it? 218 degrees Celsius, not 300. Okay. The climate of Neptune, like Jupiter and Saturn, the Neptune has an internal heat source which radiates more energy than the energy Neptune is receiving from the sun. So this causes surface winds to reach extremely high speeds. So many of these winds interfere with one another, causing small storms or large storms. So these are called, you can see here, just like Jupiter has a red spot, Neptune has a dark spot. Now Neptune's dark spot is, it's very dark and about 1 by 3 the size of Jupiter's great red spot. And it moves west and winds around it can be measured blowing up to 2,400 km per hour, and the fastest winds in the solar system.
Excuse me, this is not a storm, right?
Yes, it is a storm.
Okay.
Yeah, it is a
So
storm.
it's just
Because
like
yes, it is just like Jupiter. It's a storm.
okay. Then
Now, yeah, the position and movement of Neptune. How long is a day in Neptune? It is 16 hours, 6 minutes, and 36 seconds. Neptune's equatorial zone takes about 18 hours to complete a rotation. And the polar region, all questions can be asked in the end of the sessions, please.
okay, ma'am.
And the polar region can take just 12 hours to rotate, much more quickly than the average. Now, how far is Neptune from Earth? Neptune is approximately 4.4 billion kilometers away from Earth. And Neptune's distance from Sun is 4.5 billion kilometers. More specifically, it is 4.5 into 10 raised to 8, 9 kilometers. Yes. So this is Neptune's orbit. This second last one, this is Neptune's orbit. And this one, which is out of the plane, that is Pluto's orbit. So Neptune follows an elliptical path around the Sun, varying its distance to the Sun at different points along its orbit. Now, how long is a year on Neptune? It is actually 164 years, 164.79 years. So now let's have a look at Neptune's moons and rings. Neptune's moons. Neptune has 14 discovered moons. Now, discovery date was in 1846. Discoverers, yeah, we discussed about them. Diameter is 2000. Yeah, this is one of the one of the satellite of Neptune, which is in Britain. It was discovered by William Lassell, and it has a diameter of 2,707 kilometers. It is the largest moon of the planet Neptune. Triton is the largest moon of the planet Neptune.
Miss, is it likely that all this diameter and discoverer and distance from Neptune will come?
No, no, no. You don't need to, you don't need to study this numbers and all. No problem. The next one is Nereid, discovered in 1949. Discovered by Gerald Kuiper. You may have heard about the Kuiper belt, right? It's his name. And this is Nair. Then
Ma'am, I've seen Triton through a different telescope.
Very good for you. Thalassa is there. Despina. These are the different Galatea, Larissa, Proteus. Yeah. Yes. These are the other moons of Neptune. Halimede, Samathe, Sao, Laomedia, Neso, etc. Yes. So,
Ma'am, I think some of the Neptune's moons are asteroids.
now, see, asteroids means many of these talk about Phobos and Deimos of Mars. They are asteroids. But when this asteroid is revolving around a planet, we call it satellite. And there are these rings. The rings has some typical names. 1989 N3 are Galley, 1980 are N2 are 11. So different names are there. Lassell, Arago, etc. And the distance and width is given in the slide. Now, albedo means it is a ratio of light reflected by a planet or satellite to that received by it. So these planets and satellites, they receive some amount of light, right? Within this received amount, how much it is reflecting back? That measure is called albedo. Albedo of Earth is actually more than that of albedo of Moon. Yes. Now let's talk about exploration on Neptune. This is the structure of Voyager 2. It had cameras and spectrometers, cosmic ray detector was there, and different antennae was there.
Ma'am, what is the gold thing on Voyager 1 and 2?
It is not in Voyager 2, it is in Voyager 1. It's the golden disk, which has 112 images of our Earth's history,
Yes.
like of humans and seven sisters of the world, our anatomy of our body.
Everybody please mute. Thank you. The Voyager 2 spacecraft is a 722 kilogram space probe launched by NASA on August 20, 1977. It was a study about the outer solar system and eventually interstellar space. And it was actually launched before Voyager 1. But Voyager 1 moved faster and eventually passed it. And it has been operating for 35 years. And yeah, the spacecraft still receives and transmits data via the Deep Space Network. The Voyager 2 is part of Voyager program with its identical sister craft, Voyager 1, and is an extended mission. So it took different data sets from many of the boundary, many of the celestial objects within the solar system and the boundary, that Kuiper belt, heliosphere, interstellar space, etc. Yes, so this is the um, slide for Neptune. We have said it about Neptune too. Now I would like to show you one more slide, which is of moons. So we know that moon is our only satellite, right? Earth's only satellite. Every day we see moon, but not in full size, but different phases. Sometimes every 30 or 27 days we see the full moon, and then it decreases, and sometimes a day we don't see the moon, and we call that day new moon, right? And later on we'll see the moon. By part we'll see the moon, just like the figure given here. So our planet's large natural satellite, the moon, is the easiest astronomical object to observe. The only scientific instrument you will need at this first is a pair of eyes. Then talk about moon's orbit. Its rotation. Moon is spinning on its axis, and revolution is the moon orbits around the Earth. It takes the moon approximately 1 month to go around the Earth. Let's see. Why do we never see the dark side of the moon? The moon has two sides. One is the near side, and the other is the far side or dark side. We always see moon near side only, because why is that? Because
Ma'am,
everybody
because the
Tidal
revolution
of
and the rotation speed is the same of moon.
It's the same of moon.
exactly. So the rotation and revolution period of the moon is same.
27.3.
Yeah, that's why we only see the near side of the moon. The synchronous rotation is the reason we never see the dark side of the moon. And over the millennia, everybody please mute Aryan. Over the millennia, the moon has become locked into a special kind of motion around the Earth, and it rotates on its axis at the same pace as it revolves around the Earth. As a result, the moon keeps the same pace towards us throughout the orbit. Excuse me, Aryan, please mute your system.
Ma'am, what is the axis tilt of moon?
Okay, let me see what is the axis tilt of moon. Actually, it is coming in the slides. You will know more about it.
Okay.
It is only 1.5 degrees. Now, the lighted side of the moon always faces the sun. See, here is an example of how we see the moon. In new moon days, it occurs when moon is between the sun and the earth. And the dark side of the moon is facing the earth, and the other side will be facing the sun. So this is what we see. This is what is happening from above. Actually, if this is sun, and you know that is sunlight. In that case, we only see this is earth. Okay, from earth, this part is lit by sunlight, and this is the part we see. So this is when new moon happens.
Ma'am, can you
And
go to the previous slide? I have a doubt. Ma'am, why is it previous?
previous.
Huh. That phase how moon rotates. Here, this one only. What we see it showing below that, why it is showing that when the first stage is just above the earth, it is showing the dark side is back and the light side is being observed by us. So when it rotates, it is showing that it is rotating, like it is revolving but not rotating.
Both is in the same rate. I mean, the rotation rate and the revolution rate is same. Okay, the
I mean, the
period is
picture
same.
is just showing like
See,
that.
no. This is actually that what we are seeing. This is a picture from above. If we are
Okay.
looking Earth from above, this is happening.
Okay.
This side we are not seeing. We are in Earth.
Okay, understood.
Okay. Now this is full moon. The full moon occurs when the moon and the sun are on opposite sides of the earth, and the lighter side of the moon is facing the sun. And here you can see this is what we see, the full moon. And what is happening from above is given here. If this is earth, when it is happening full moon, earth is in between moon and the sun. Here you can see an arrow. Sunlight is coming from this side, okay? Take pointer. And so this is a sunlight arrow, and this is earth. So what we see is, okay, the full this part of the moon is lit. So we see this part as full moon, while the other part it is dark.
Ma'am, I have a doubt.
Yes.
Ma'am, how when we see the moon, the sunlight of sun is reflected on the moon, and that's why we see the moon. So, when the lunar eclipse occurs, the Earth is between the moon and the sun. So the sunlight from the sun is not reaching the moon. So how we can see the moon, full moon?
When full moon is happening, moon and sun, the earth is between moon and sun. Okay.
Yes.
So of course light can reach here. What do you think, light won't reach in this line? No, it can of course reach here. That's why we see the full moon.
Ma'am, because the shadow of the Earth will be
Oh,
cast
no.
on the moon.
No, when it is in the straight line, we won't get it. But of course, it won't be in a straight line, right? If it is a straight line, we call it eclipse. This is not an eclipse situation. This is just, it will be behind. It will be maybe upper or down side.
Oh.
Yes. And now the full moon. The full moon is given different names depending on when it appears. For example, the harvest moon is the full moon that appears near to the autumnal equinox, occurring in late September or early October. Some other full moons named by the month. You can see here in January, moon after Yule, wolf moon or old moon. February it is called snow moon or hunger moon. So just like that, there are different names for these full moons in different months. It's just fun to study these names. Now, blue moon. So you may have heard about blue moon. So it's nothing about bluish color of the moon. It's nothing
It is
like
a
that.
phenomena relating to the orbit of moon.
Yeah. When there is more than one full moon in a month. So if there is full moons in a month, we call it blue moon. It happens every 2 years on average. So that's why there is this phrase to use, like once in a blue moon. So which means very rarely. Okay. So this is blue moon. It's not that the color of the moon will not be blue actually. This is a fun picture. Color will be the same color, like just like we see the moon. But
Ma'am,
the
I
thing
think
is,
it happened the last year.
yeah, okay.
And what is super moon?
Yeah, we will come to that. Now, this is the first quarter moon. The first quarter moon occurs when the moon is halfway between new and full. So this is the first quarter. This is what we see, and this is what happening from the above. See, sunlight is coming from this side. This part is lit, but from Earth, when we look, only half is visible. Half is dark, right? Just like that. Did you understand, everybody? Sunlight is coming from this side. We are this blue Earth. So when we look from here, only half is visible. Half is dark. This part is visible. So when we look, we'll get only this much, like half of the moon will be visible. And this is the third quarter. The third quarter or the last quarter moon occurs halfway between the full moon and the new moon. So it will be on the other side. Again, sun will be lit on this side and won't be there in the dark side. So we will see a half moon just like the first quarter. And these are the waxing and waning of moon. We say that, right? So when the moon is between new and full. So when the moon is from new moon means we won't see the moon at all. Like this, dark. And from that we kind of, a small part, a crescent will be there, and the first quarter will be there. Then, most of the moon will be visible, and then there is full moon. These phases are called waxing of moon. Okay. And yeah, this is waning of, which means that from full moon to when the moon is disappeared, it's called waning. So hopefully you understood about waxing and waning.
Yes.
Yes, very good.
Ma'am, can you just explain it again?
Yeah, sure.
No, ma'am.
Okay. So there is waxing and waning. We are talking about different phases of moon. And there is waxing and waning of moon. So waxing of moon means that during new moon, no moon will be there. Like we can't see the moon, right? It's all dark. From the dark side, this is the new moon. So from Earth, when we look, this is the new moon. When we are looking from Earth, we won't see any dark, right? We just see the dark, right? Let me take the pointer. Yeah. Hopefully you can see the pointer. We are standing here. Okay, here we are standing and looking at the moon here. Sunlight is coming from this side. Okay, so this side is lit, but we can't see this side because we are on Earth. So we see dark. So slowly, when it comes from this side to this side, what happens? So slowly it will be visible. So from new moon day to full moon day, it is called waxing period. Waxing moon, we call it when the moon is between new and full. Okay, from new moon to full moon. Part by part, you will see the moon. This is called waxing.
Thank you, ma'am.
No problem. Just like that, when it is waning, we see from full moon to new moon. So this is the full moon. From full moon to new moon, part by part it will be not visible, and in the new moon day we won't be visible, we won't be seeing anything. So these are the crescent moon phases when it is here, 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 and here. The third quarter and first quarter. So crescent moon is when the moon is between the new and first quarter, and it is called waxing crescent. So you know that waxing means the previous slide we saw from new moon to full moon, right? So this is actually the this you can see slowly it is coming, right? It is visible. So crescent moon is when the moon is between new and first quarter. It's called waxing crescent, and this is it. The waxing crescent. And when the moon is between third and new moon, third and new moon, this side, it's called waning crescent. So it's very important to know about waxing crescent and waning crescent. If you have any doubt, you can ask now. It may come in the exam.
No, ma'am.
Okay, I'll tell you. You
Ma'am,
understand?
which is the only, is there any planet which has no axis tilt?
Yeah, many planets. For
Mercury.
example, Mercury and Venus, they doesn't even have a good
Means
axis, and
like,
also Jupiter.
they like don't have an axis tilt.
No, very, very feeble. Even Jupiter's is just 3 degrees or so. But Mercury and Venus almost vertical, yeah.
Excuse me, miss.
And
Yes.
does sun have an axis?
Miss, excuse me. So, why do the moon have phases but planets don't?
Maybe some of the planets has phases, but Venus has phases.
Venus has none.
Yes. Other planets,
Miss, and what is the
Oh.
tilt in the orbit of moon?
it is, yeah, it's just 1.5
1.5
degrees.
degree. Ma'am, does sun have an axis tilt?
No, sun's axis is considered to be standard. We always consider our own, axis with compared to the sun. So sun's axis is said to be, yeah. But also it can be said that like it spins on its axis in a tilt of 6 degrees, which is 6 degrees from the orbit plane of major planets.
Ma'am, I have a doubt.
Is it okay that if after completing this slide we can ask doubt?
Okay, ma'am.
But
Hopefully,
if the tilt in the rotational axis of moon, it is showing as 6.688 degrees, and the tilt of the orbit of the moon it's showing as 5 degrees.
it's the orientation of its axis, which is only tilted by 1.5 degree. With respect to, with respect to Earth, it is 5.15. But with respect to, the orbit, its own orbit by which it is revolving Earth, it is 1.53. Okay.
Yes.
So I hope you understood crescent moon, like waxing crescent and waning crescent. So waxing crescent is between new and first quarter. It's very important. May come in the exam. And waning crescent is between third and new. Okay. Then now let's talk about gibbous moon. When the moon is between first quarter and full, it's called waxing gibbous. So this is the waxing gibbous. That is it between full, see the first quarter and full. This is the first quarter and full. When it is between first quarter and full, it's called waxing gibbous. And when the moon is between full and third here, it is called waning gibbous. Okay. Yes. So here you can see new moon, waxing crescent, first quarter, waxing gibbous, full moon. Then waning gibbous, last quarter, waning crescent. Again, new moon. This is the cycle. Yeah, this is the moon slide. Yes, now let's talk about the questions.
Ma'am, I have a doubt.
Yes, please.
Ma'am, what is supermoon?
Oh, yeah, I didn't say about that. I'll tell you.
Miss, there is a
Let me answer this.
What, ma'am?
So it's actually a phenomenon whereby the moon appears particularly large in the sky. It's because it is closest to
ma'am?
the, because it is close, having, its closest approach towards Earth. It is closer to Earth.
Is the orbit of moon elliptical?
Yes, it is.
So means it it has a 5-degree angle of the, so in that orbit it comes near.
Okay, I'll tell you. Everybody please mute. Some noise is coming. Yeah. See, Chakri, please mute. I think it's from your, I'm not sure. Everybody please mute. Yeah. What's that? Yes. So, moon revolves around Earth in an elliptical orbit. So when sometimes there is closest approach and sometimes there is farthest approach. When the moon is close to Earth, we see bigger moon. So such moons are called supermoons. Is there any other question?
Ma'am, I have a doubt.
Yes.
Ma'am, means at night time, we, if the moon is in the first quarter or last quarter, how can we see the moon? Because the moon is in the side, and if we are in the night time, we will be straight ahead, and the moon will be in the side. How can we see the moon that time?
Just like this, we see the moon, right? Always. So if the sunlight is from this side, we are saying here. Of course, we can see here. See, half of the moon we can see here.
No, ma'am.
And half. Okay, 1 second. I'll show you a video of how moon's phases are there. Then you'll understand. Where is the moon now? It's actually here because we can see it. Because it is next to the sun, right? It's much, much brighter than anything else in the sky. The sun is very much brighter, so we won't see that. That is the new moon. Just you saw that new moon. Okay. Now, see. So during new moon, it's between Earth and sun. That's why we cannot see it. This is the side which is facing towards us. Actually, every day the moon rises around 50 minutes later than the day before. Okay. So this is new moon day. We won't see the moon at all. That's why we won't see the bright. When the sun sets, we can see a small part of it. That's it. So See, after some time it rises here. Understood?
Ma'am, I have the doubt here.
Yes.
Ma'am, now see, the moon is in the side, and they're seeing it at night. So
Not
how?
only at night. See, morning and night. Sometimes we see moon in the morning also. Haven't you seen it in evening times and all? Haven't you seen the moon on morning and all? Not
Ma'am,
only.
I have not seen an evening.
Oh, okay. So that's it. It is visible in the daylight also sometimes. Okay. And that depends on in which phase the moon is in.
Okay.
Understood? Yeah.
Yes, ma'am, I have seen it.
Yeah. So this is the first quarter moon. The Earth is revolving. Actually, this takes 27 days to complete one rotation. But Earth is rotating on its own axis in 24 hours, right? So of course we will see it. So this is full moon. There was a doubt, right? You will understand it now. So what happened? It's in the opposite side, right? I hope you understood about this moon's phases, right?
Yes, ma'am.
Very good. So yes,
Yes, ma'am.
if there is any another doubt,
Ma'am, I
can
have
ask.
another question.
Sorry.
I have another question. Is
Yes.
it possible for any planet not to rotate?
Sorry. Any planet
Is it possible for any planet not to rotate?
not to rotate? No, actually, no planet is staying still. In space, everything has to move. Movement. For example, let me ask you a question. When you ride a bicycle, it has two wheels, right? If it is riding, of course, it will get the balance. It will go on riding, right? If you stop the bicycle, will it stay upright?
It'll fall over.
Yeah, just like that in space, everything has to move. Movement is crucial. Nothing can stay still because everything is, related to some other materials, gravitationally related to some other material. So movement is crucial. There is no any planet that we have found which is not rotating.
Also, ma'am, I have another question related to this. What
Yes.
makes the planet rotate, or does it just start rotating on its own when it's formed, or like does some external force have to be applied?
For example, when Earth was formed in the solar nebula, the whole nebula was rotating. You remember that?
Yeah.
If something was generated out of something which was already rotating, it's common to have, the rotation for the planet also, right?
Yeah.
Just like that, many of these things, many of the origin of things are joined with this rotation motion. So it is like it's one of the common motion in the universe that things rotate.
Okay, ma'am. Thank you.
Yeah, thank you. Is there any other doubts?
Yes, ma'am.
Yes, please.
Ma'am, I have heard that the moon is upside down in both the hemispheres.
Straight down.
Yes.
You mean?
Ma'am, like in northern hemisphere, for example, if I choose a spot like on the moon, uh, Mars Twinkle, what is that? I don't know, but the pronunciation I don't know. But it is a spot.
Okay. So
So,
it's called that. Yeah, yeah, understood. It's like Because a person standing on Earth's north pole is upside down compared to someone on the south pole, their perspective of the moon would be upside down as well. It's just like, when you are looking at moon from our both hemispheres, our the way we look is different, right?
Yes.
Yeah, there is also one more picture I can show you that. Yeah, you see this? When we are in the northern hemisphere, we see this is the top and this is the bottom, right? And when we are in the southern hemisphere, we see this is the top and this is the bottom. That difference is there. In northern hemisphere, sun looks like this. We are in northern hemisphere, so sun looks like this. And in southern hemisphere, moon looks like this.
Oh,
Okay,
okay.
got it? Yeah.
Yes.
So I wish you all the luck for the exam and your future venture. And hopefully we will see in the next session.